This video is going to be shorter than the previous. I just want to do two more examples, couple little things I want to point out that may help you before you finish the whole assignment with implicit differentiation. So I actually copied this one directly from Delta Math, so you're used to the wording and the way that the problems are presented. So they're going to give you this equation that's written implicitly. They're going to ask you to find the derivative, and they do remind you that your answer will be in terms of both x and y. The other thing I liked about this one, I say liked because it's going to help you, not because it's necessarily one that I enjoy, you have a lot of minus signs here, and minus signs are so easy to get mixed up along the way. So I want to talk about that because that seems to be a common mistake that often gets made on these. So we're going to start with the derivative of the first term. The derivative of negative y squared is negative 2y dy dx. Here's a product rule. As I said, expect your product rules. Also have a negative in front of your product rule, which what that actually ends up doing is when you write each term of your product rule result, they will both be negative. So you're going to have the first times over the second. So you're going to have a negative x squared times the derivative of y, which is dy dx. But then normally you have plus the second times over the first, but you know that this negative is going to be distributed. So you actually are going to have a minus. The derivative of x squared is 2x times the second function. You do not have a dy dx here because you did not derive a y piece. Then the next one is negative x squared, so negative 2x is its derivative. And then on this side, don't get caught up in the negatives, that is just 0 because it is a constant. So I'm going to move the two that don't have dy dx to the other side. So when I do that, they're actually going to be positive. So I'm going to 2xy and a plus 2x. If you want to start skipping steps, again, let me show you what I mean by you can start skipping steps if you want. You can factor out a dy dx and write down what's left at the same time, if you're comfortable with that. If not, do it one step at a time. And then finally divide both sides by this negative 2y minus x squared. When you type it into Delta Math, just be careful that you have the right pieces on the top, the right pieces on the bottom, and watch your signs. It's truly the negative signs are one of the biggest mistakes you'll see, especially when you have a lot of them like you had to start in this problem. That is your answer for your derivative. So I want to show you that so you can get used to derivatives with negatives, and you could also get used to the Delta Math format. The last one I want to do is kind of an extension of where we'll go tomorrow with this lesson is, again, the whole idea of deriving is so you can find an equation to represent slope. Now, when you do that with implicit, you actually will utilize both coordinates for slope, unlike explicit, where when you're done, all I have to do is tell you x equals 2 or x equals 3 or x equals 1, and you can find the slope. Because the way implicit are written in terms of x and y, you will need both x and y to be able to find your slope. So let's start this one. The derivative of negative 3x is negative 3. The derivative of y cubed is 3y squared dy dx equals, the derivative of 5 is 0, and the derivative of negative x squared is negative 2x. So I'm going to bring the 3 to the other side. So I have 3y squared dy dx. This one's actually a pretty short actual derivative one, equals negative 2x plus 3. And then I'm going to divide both sides by 3y squared. So here's your derivative. The directions, however, want to find what the derivative is at 4, 1. So it's another way of basically saying what's the slope at 4, 1. So you're going to put 4 into your x value. So you're going to have 2 times 4 plus 3. And you're going to put 1 into your y value. And you may have one that have lots of x values and lots of y values. This one wasn't too bad. So we get negative 8 plus 3 is negative 5 over 3 times 1 squared is just 3. And so that is the answer that you will type in. And that will represent the slope of the tangent line at 4, 1. You could even go a step further and actually write the equation of the tangent line by taking the coordinates. And the nice thing is they gave you both. And you could write y minus 1 equals negative 5/3 x minus 4. But with the ones you're going to work on today, you are just finding the numeric value, the slope. So that gives you hopefully a really comfortable introduction to what implicit differentiation is. We're going to extend it. We're going to do more with it next class, but this gives you a good start.